Okay, hope everybody's doing well. I decided to re-record this and add a couple of extra things in here to help you out, okay? So this is the review for exam 2. It'll be on Wednesday, this coming Wednesday, okay? This should help you, and we've already went over all these problems, so this is just a review. First, I want you to study the true and false on page 66, but also I want you to think about a few questions here. What is the constant in a series circuit? What is always the same? And remember, that is current. Current is always the same in a series circuit. What does IR mean? That's current times resistance. And what is current time resistance? Well, that's the voltage drop. A times IR is voltage drop. Total power. How do we find total power? Remember, total power, power T, is P1 plus P2 plus P3, etc. Okay, you just add them all up, and that's our total power. Total voltage, same thing. VT equals V1 plus V2 plus V3, on and on and on. Resistance, R total is R1 plus R2 plus R3. Again, these are only for series circuits, okay? We're going to do something new when we start parallel. So what is the resistance in a short circuit? Remember, in a short circuit, which is where it's shorted across a resistor, it's going to equal 0 ohms. In an open circuit, where the circuit is open, that's going to equal infinity. Okay? So that's how we do those problems. All right. Now, let's look at this first problem. What we have to do is we have to look at what all we have. We have R1, R2, and R3, and we have voltage total. So we don't have current, so we need to find current. We need to find V1, V2, and V3. Then we need to find each of the powers, okay? So anytime we have all the resistors and voltage, then the first thing we need to do is find R total. And R total, remember, equals R1 plus R2 plus R3. In this case, we have 3 resistors. So that's going to be 680 ohms plus 820 ohms plus 1.5K. Now remember, that's 1.5 times 1,000. So that's going to be 1,500 ohms. Okay, when we add all that up, we end up with 3,000 ohms or 3K ohms for R total. I want you to show your work and circle your answer. So we'll put R total, R total here. If you accidentally hit any of this, it goes away. R total equals 3K ohms, okay? R total equals 3K ohms. Now, so we found R total. After we find R total, we can find I total. I total equals V total over R total. V total is 45 volts over 3,000 ohms. We do that calculation. We get, in the calculator, we'll get 0.015 amps. And that's fine to put that down for your I total. But that also equals, just to get you practice, is 15 milliamps. You've got to get started where you can go back and forth, okay? All right, so we got I total now, 15 milliamps or 0.015 amps, which is what you'll put in your calculator, okay? Now that we have I total, we can find V1, V2, and V3. So from Ohm's law, V1 equals I total, because I is constant throughout the circuit, times R1. I total is 0.015 amps times R1, which is 680 ohms, and that's going to equal 10.2 volts for V1. Circle your answer, show your work. 10.2 volts. Same thing for V2. That's going to equal I total now times R2. 0.015 amps times R2, which is 820 ohms. Now notice if you put 15 in, your voltage is going to be really high, okay? 12.3 volts. Just ignore that, I'm sorry. V2. Still having trouble with this computer sometimes. 12.3 volts for V2. I'll rewrite it. Okay? So now we've got V1 is 10.2 volts. V2 is 12.3 volts. And now let's find V3. V3 is going to be I total times R3, 0.015 amps times, now this time you're going to put in 1500 ohms. And that's going to equal 22.5 volts. Or V3. 22.5 volts. V2 was 12.3 volts and V3 was 22.5 volts. Now, if we take and check this, V total should add up to all these. V1 plus V2 plus V3. So 10.2 plus 12.3, 22.5 equals 45 volts. So that's correct. So we just put a check mark there, okay? Now we need to find, have we found P total? No, we need to find P total also here. So to find P total, that's going to equal V total times I total, because power is voltage times current, remember? So V total is 45 volts times 0.015 amps, and that's going to equal 0.675 watts, and you can leave it at that, or it's going to equal 675 milliwatts for power total. And that's what I prefer to do. But again, if you leave it at 0.675 watts, that's what you would put in your calculator if you had to solve something else, so that's fine. So then P1 is going to be V1 times IT, again, current's the same. V1 is 10.2 volts times 0.015 amps. So P1 is going to equal 0.153 watts, or 153 milliwatts for P1. Again, make sure that you show your work, okay? I'll give credit sometimes when you show your work, depending on how you do your calculation. If you just miss it by a decimal, you get partial credit. If you don't and show your work and you just give me an answer, you get no partial credit. So V2 times IT. Now V2 we found to be 12.3 volts times 0.015 amps. And again, once you get one of these, it's just a matter of finding all of them. It's the same thing all the way through it. So that's going to equal 0.1845 watts, or 184.5 milliwatts for P2. Okay, P3 is going to be V3 times IT. V3 is going to be, what's V3? V3 is 22.5 volts times 0.015 amps. And that's going to equal 0.3375 watts, or 337.5 milliwatts for P3. Okay, so we're done. We got it. Now, remember from a while ago what I said, all of them need to add up to P total. So P total equals P1 plus P2 plus P3. And when you add all that up, you're going to get 675 milliwatts. And that's the way to check your answers to make sure that they're correct. If you don't get that, then you've made a calculation error somewhere. Okay? All right. So the next type of problem we have is one with unknowns. And you're going to have 2 of these. I'm only going to work one, but if you can do one of them, you should be able to do both, okay? Now remember, with unknowns, look at your formula sheet that I gave you at the beginning. You can use your formula sheet because sometimes it may not just be your basic circuit VIR, okay? You may have to use one of those weird formulas. So just keep that in mind, okay? And you've had several like that in your homework, so you should be okay. All right. So let's look at this one. We have R1, R2. We don't have R3. We don't know what it is, but we have V3. They gave us 4 volts. We also have our current, which is 400 microamps, and R4, and we don't have VT. Okay? Now, first of all, let's look at 400 microamps. Remember, that's micros times 10 to the negative 6. So if we move this decimal place 6 places, that's going to be 0.0004 amps. That's what you're going to have to put in your calculator. If you put 400, your calculations are going to be way high. Next, you need to look at what you're given and what you have. Well, we have R1, R2, and R4 and V3. We also have current. So we have 2 of the 4. So what we need to find first then would be V1. We can find V1 because we have current. We can find V2 and we can find V4. Okay? We can't find R3 yet, but we'll come back to that. So V1 will equal IT times R1. IT is 400 microamps or 0.0004 amps times R1. That's 15K, so that's also 15,000. Remember, it's 15 times 1,000. So that's going to be 15,000 ohms. And that's what you need to put in your calculator. Because if you put 400 times 15, you're going to get, let's see what you're going to get. 400 times 15. You're going to get 6,000 volts. Well, we know that this is not a 6,000 volt circuit. 6,000 volts would be way, way too high. Even though we don't know what the rest of them, we know V3 is 4 volts. So that tells us right there that would be way too high. Okay? So you need to put in your actual values, which is 0.0004 times 15,000. So when we put that in, we get 6 volts. So sometimes you just have to use logic a little bit, okay? So 6 volts there. Then we can find V2. That's going to be IT times R2. IT is 0.0004 amps times R2, which is 22,000 ohms. And that's going to give us 8.8 volts for V2. Okay, so 8.8 volts. We can't get R3 yet, but we have V3, but we can come back to that in a minute. Let's find V4. V4 is IT times R4, 0.0004 amps times 33,000 ohms. Okay, so we do that calculation, we get 13.2 volts for V4. Okay, so we got V1, 6 volts, V2, 8.8 volts, and V4, 13.2 volts. Okay, and we have V3. So in that case, let's go ahead, we can find VT total. V total is going to be V1 plus V2 plus V3 plus V4. So that's going to equal 6 volts plus 8.8 volts plus 4 volts plus 13.2 volts. When we add all that together, we get 32 volts for VT. Okay, very good. VT equals 32 volts. All right. Now, since we have that, we're still missing R3, but because we have VT and IT, we can find RT by our formula. RT equals VT over IT. VT we just found is 32 volts divided by 0.0004 amps. So RT is going to equal 80,000 ohms or 80K ohms for our total. So our total goes here. Alright. Now we can find R3. So once we have we can say, there's a couple ways. You can do RT minus R1 minus R2 minus R4. When you calculate that, you're going to get 10,000 ohms or 10K ohms for R3. Or another way you could solve it would be R3 equals V3, because we have V3 there, divided by I total. V3 is 4 volts divided by 0.0004 amps, and that's going to equal 10K ohms. So there's two different ways you can do it and check your work. You only have to do it one way, but that's whichever way you like the best, okay? It don't matter to me. So R3 is 10K ohms. Now we need to solve for PT, P1, P2, P3, and P4. So let's just do that over here. So first of all, let's do let's solve for PT. I don't think I did. So PT is going to equal VT times IT. VT was 32 volts times 0.0004 amps, and that's going to equal 32 times 0.0004 is going to be 0.0128 watts, or if you move it 3 places, 12.8 milliwatts for P total. Okay, and then P1 is going to equal V1 times I total. V1 is 6 volts times 0.0004 amps, and that's going to equal 0.0024 watts or 2.4 milliwatts for P1. P2 is going to equal V2 times I2. V2 is 8.8 volts, and you can go back and look. V2 is 8.8 volts times 0.0004 amps, and that's going to equal 0.00352 watts or 3.52 milliwatts for P2. I hate when it shoots that line up like that. P3 is going to equal V3 times I total, and that's going to equal 4 volts times 0.0004 amps, and that's going to equal 0.0016 watts or 1.6 milliwatts for P3. And then P4 is V4 times I total, and that's going to be 13.2 volts times 0.0004 amps, and that's going to equal 0.00528 watts or 5.28 milliwatts for P4. Now if we add up P total to check, P total equals P1 plus P2 plus P3 plus P4. You add all those up, you should get 12.8 milliwatts for P total. And so that checks out, and we're good. We did it correctly, okay? So a lot of this is just repeat once you figure out what you need, okay? Now remember, you're going to have 2 of these. You will also need to use your formula sheet to see what you need. Always look and see what you have. Write that down first and work your way back, okay? So practice the homework problems I gave you on the unknowns and look at the examples. All right, the next type of problem is going to be your potentiometer problem. Okay, so this one we just have two resistors in our potentiometer. Our potentiometer goes up to 2.5K, 0 to 2.5K. So we have everything we need. So the first thing when we have everything is to find our R total. So R total equals R1 plus R2. So that's going to equal 10K ohms or 10,000 ohms plus 2.5K, 2.5 times 1,000 is 2,500 ohms. And that's going to equal 12,500 ohms or 12.5K ohms. Okay, so that's R total. So R total equals 12.5K ohms. Alright, so now we have R total and V total, so we can find I total. I total is V total over R total. V total is 25 volts over R total, which is 12.5K or 12,500 ohms. Remember, that's what you have to put down to get your correct calculation. So when you do that, you get 0.002 amps or 2 milliamps for I total. Okay. Once we found that, we can find P total. Let's put these in real quick. P total is V total times I total. So that's going to equal 25 volts times 0.002 amps. So P total is going to equal 0.05 watts or 50 milliwatts. Okay. Once we find all that, we have current, we can find V1 and V2. So V1 is IT, current's the same throughout the circuit, times R1. IT is 0.002 amps times R1, which is 10,000 ohms. And that's going to equal 20 volts for V1. Now, we can either say VT minus V1 is 5 volts left, or we can calculate it. So let's just calculate it. IT times R2, 0.002 amps times 2.5K or 2,500 ohms is going to equal 5 volts. And that's what we expect it to be. So if you didn't get that, then you know you made a calculation error somewhere. Remember, your voltage cannot add up to more than the applied voltage. 20 plus 5 is 25, and that's the applied voltage. Okay, so now we just need to find P1 and P2. So P1 is I total times V1, 0.002 amps times V1, 20 volts, and that's going to equal 0.04 watts or 40 milliwatts for P1. P2 is going to be IT times V2, 0.002 amps times V2 is 5 volts. It's going to be 0.01 watts or 10 milliwatts for P2. Okay, and we know what PT is. It was 50, so 40 plus 10 is 50, so that's correct. So we know that we're on the right track. If you got something different than what adds up to the total voltage or power, you know you're wrong. Okay, all right, now voltage range. Okay, so we just look at P2. P2 is, or V2 is 5 volts. So at 0 ohms, our voltage then would be what? 0 volts. At 2,500 ohms, our voltage would be what? 5 volts. So our voltage range is 0 volts to 5 volts. Okay? That's all that means there. That's our range. Just like our Remember, for a potentiometer, our range is 0 to 2.5K. Okay, so that's how you do that. The last type of problem we're going to have is your favorite, the troubleshooting problems. Okay, so I'm going to try my best to get this, to make it easy for you, okay? Our good circuit is here on the left. We have VAG, so that means our voltage from A to G is 12 volts. Our voltage from B to G is 8 volts, and our voltage from C to G is 4 volts. Our resistors are 1K each. So we could calculate what each one of these would be and find out what V1, V2, and V3 is. We know that C to G is 4 volts, so we know that's 4 volts. We know our total voltage is 12 volts. So if from B to G, adding these two together, this one also has to be 4 volts, because 4 plus 4 is 8. If that's the case, 12, then we know that this one's 4 volts, because that's going to be 4 plus 4 plus 4. Okay, so that's how we do that's the good circuit. So on the first one, let's look at our second circuit. Now remember, VAG just means you're measuring from your power supply plus voltage to your, and our voltage total here is 12 volts. Okay, this is our total voltage. That just means that it's from 12 volts to ground. Now, but we know that VR1 equals VR2 equals VR3 because they're all 4 volts from our good one. Now, if any of the voltages are larger than 4 volts, we have a short somewhere because they should all be 4 volts. Note, VCG is the same as V3. So let's look at this. VCG is 6 volts, but we know it's supposed to be 4 volts. VBG is 12 volts, but it should be 8 volts. And VAG is 12 volts, and it's showing 12 volts, okay? But we know that if it's higher, and VCG is higher than 4 volts, we know there's a short somewhere. So if the resistor is larger than the good resistor, we have a short somewhere, okay? But we got to keep looking. So VBG is 12 volts is what we're measuring here from B to G, and we know it should be 8 volts. So again, that's larger. So we keep moving up till we figure out which one it is, okay? So VAG is 12 volts, which is okay, but if VBG is 12 volts and it's supposed to be 8 volts, and VCG is 6 volts, and it's supposed to be 4 volts. That's larger. That's larger. So then we know that the short is at R1. So we keep working up until we figure out which one it is. If they continue to all be higher, then the R1 is the short. Okay? Let's look at another one. We know the good one, that this is VAG, is supposed to be 12 volts. VBG was supposed to be 8 volts. And VCG was supposed to be 4 volts. That's good, okay? But in this one, we've got VAG is 12 volts, so we're okay. VBG is 6 volts. Now it's lower than the 8 volts. And VCG is 0 volts. So in this case, we look at VBG and it's 6 volts. Now, it's supposed to be 8 volts, but remember, VR1 is supposed to be 4 volts, which is equal to VR2, which is equal to VR3. So they were all supposed to be 4 volts. And we notice that VBG is 6 volts. Well, if it was correct, it would be 8, and we know this resistor is supposed to be 4. Okay, so let's keep looking. Now, VCG is 0, okay, but it should be 4 volts. So now this one dropped all the way to 0, and this one's higher than 4 volts, but it's not 8 volts. So in that case, we know that R3 is shorted. So we didn't have to go up any higher because of this 0 volts here, okay? Now let's look at the last one. The last one, we know VAG is okay. It's, ooh, what happened? Didn't mean for that to happen. Sometimes they have some secret buttons here that I don't even see. So VAG is 12 volts, VBG is 0, and VCG is 0. We know that this is supposed to be 12, 8, and 4. So if all these are 0, but we're getting the total applied voltage here in 0, we know that R1 is open. And the reason we know that is because we can get 0 to G from here to here, but if we're not getting anything from here to here, that means it's open right there. Okay, so R1 is open. And that's going to be it for the test. That's all you have to do, okay? So please look over this video, look over your homework that I assigned to you. Go ahead and look at the odd one. I did the even one on this last problem. Go ahead and look at the odd one, which is the one I gave you for homework that we went over in class today, and try to understand it from this lecture, okay? Remember the 3 rules that we talked about in class. And if you have any questions, I'll be in my office tomorrow, and I'll be glad to help you, okay? Hope you guys have a good night, and I'll see you tomorrow.